Hello, ladies and gentlemen. I once again welcome you to my integral calculus online lessons. This is my third lesson in integration. In the second lesson, we talked about the integration of sine x and cos x. We also introduced exponential functions. We went ahead to talk about the integration of involving functions of linear functions of x, but we didn't go so much into the details. Today we want to continue with that, but before we move on, we have to know how to integrate some of these trig functions. Let us see, how do we integrate sec squared x? How do we integrate cos x squared x? Okay, let's look at this. These integrals are developed from differentiation. Okay, we must know what do we differentiate to get sec squared x, to get cosec squared x, to get sec x tan x, and cosec x cot x. Okay, we know that d by dx of tan x, the derivative of a tan is sec squared x. Okay, so what does it mean? If we integrate sec squared x by dx, it will give you a tan x plus a c. Careful here, I'm saying the integral of sec squared x, not integral of sec x. Remember, we are recognizing functions, okay, and their derivatives. So we are looking at sec squared as coming from tan, okay? When you differentiate tan, you get sec squared. So integrating sec squared, it will give us tan x, okay? So what about if we differentiate cot x? What do we get? We end up with a negative cosec squared x. So it means that if I integrate a negative cosec squared x, it will give me cot of x plus a c. But I can divide through by negative, and I have the integral of cosec squared x giving me negative cot of x plus a constant of integration. Okay, so d by dx of sec x, I end up with sec x tan x. Okay, meaning that if I integrate sec x tan of x, it will give me sec x plus a constant of integration. Lastly, if we are to differentiate, okay, cosec x, we end up with a negative cosec x and then cot x. So what does it mean? If I integrate a negative cosec x cot x by dx, okay, then it takes me back to cosec x plus a constant of integration. So integrating cosec x, then cot x by dx, that's now dividing through by negative, end up with minus cosec x plus a constant of integration. So dear friends, be careful with these integrals. Integration, you must really be extremely careful. Okay, you must know what you are trying to integrate. Do not find the integral of sec x by dx and then you rush to say that this is going to be tan of x plus sc. Be careful, this is not true. Okay, you must know that I have to differentiate this function to end up with the other function. So you now perform a reverse process. Integration, okay, you have to be extremely careful. Next, we discuss an important integral that involves natural logarithms. Remember, okay, we said that to integrate a power of x with respect to x, you end up with x to power n plus 1 over n plus 1, okay, plus a constant of integration, provided the n is not equal to -1. Now, what happens when n is equal to -1, okay? If n equals to -1, okay, then integral of x to power -1 by dx will be the same thing as the integral of 1 over x by dx, okay? But how do we go about that? The key point is go back to differentiation. Look at which function do you differentiate to get 1 over x, okay? But d by dx of natural logarithm of x, okay, it will give me 1 over x, okay? So this means that if I integrate 1 over x by dx, it will take me back to natural logarithm of x plus sc, okay? So we have discovered an important integral today, and that's going to play a very, very key role in the area where we are heading next, okay? So let's look at this in general. But now, from this point, okay, let me generalize it with a function u. So you don't only think about x. Natural logarithm of u, okay, is 1 over u. So this integral is with respect to u, not x. So this means that if I integrate 1 over u with respect to u, I end up with the natural logarithm of u plus sc. Yeah, you know why I prefer to use u? U could represent any function of x, okay? Whatever function of x we want, we can now use u, use the substitution u, and find it very easy for us to. So every time we find the integral 1 over u, okay, then it's going to take us natural logarithm of u plus sc, okay? Now, I have to give you a hint. If we are given to differentiate, let me say with respect to x, you want to differentiate a function of x, okay? The hint is this. Write 1 over that function of x, then differentiate the function, okay, f of x with respect to x. So you write 1 over the function times the derivative, okay? What does it mean if, oh no, this is natural logarithm of a function of x, okay? So d by dx of natural logarithm of, let me say, this is 2x plus 1. I want to differentiate natural logarithm of 2x plus 1. So this will take me to, I write 1 over 2x plus 1. Then I go ahead and differentiate d by dx of 2x plus 1, okay? So in the end, I have 2 over 2x plus 1. And the integration now is going to be very simple. We perform the reverse process. What does it mean? If we integrate 2 over 2x plus 1 by dx, then we end up with the natural logarithm of 2x plus 1, then plus a constant of integration. So that's why I mentioned in lesson 2 that it is very, very important for one to understand differentiation before moving on to integration, okay? So now let's now move to what we call a function is of a linear function of x. All right, the discussion is moving on well so far. We want to talk about functions of a linear function of x, okay? You want to integrate a function which is involving a linear function of x. For example, integral of 5x plus f4 cubed by dx, okay? We want to integrate the function of emphasis is 5x plus f4 cubed. But when you look at 5x plus f4, that is a linear function of x. If I make it maybe u, I substitute 5x plus 4 by u, then I will have u cubed, and I'll be integrating u cubed, where u is a function of x. It's a function of a linear function of x. So how do we go about these integrals? Okay, the key is to use, let me put in a better language, is to use substitution. Okay, if you want to integrate these functions, use substitution. Okay, here I will let you can call it V, whatever you feel like. Okay, you have learned the alphabet and you are reaching those 24 letters, so you pick one of them, but I prefer u is equal to 5x plus f4. So if I differentiate du by dx will be equal to f5. Okay, make dx the subject. Okay, this means that my dx is du divided by 5. Okay, so the integral, instead of integrating 5x plus 4 cubed by dx, we want to integrate u cubed, then du over 5. Okay, and this is going to be u, okay, to power 4 over 4, as the rule of integration is, then times 1 over 5. Okay, and the final answer will be 1 over 20 of u. But what is u? Put it back. It is 5x plus 4 to power 4 plus a constant of integration. You are done. You have integrated a function of a linear function of x by substitution. Okay, let's look at this. Okay, what about if we have been told to evaluate, or let me get organized, ladies and gentlemen. Don't want to be disorganized. Okay, suppose I had called this example 1. This is example 1. Now I want to talk about example 2. Example 2 is telling me to evaluate which integral? The integral from -2 to -1. And what are we integrating? Dx 1 minus 2x. Okay, look at that integral critically. Let's see how we go about it. We want to evaluate from -2 to -1. And what are we really evaluating? This is, let me write this well, -1. From -2 to -1. Okay, so the key is 1. Let u equals to 1 minus 2x. Now, if u is 1 minus 2x, you want to go ahead and change also the limits. Okay, you have x and you have u equals to 1 minus 2x. So the limits are -2. Okay, so if u is equal to 1 minus 2x, 2 times x will be a -4. So 1 minus a -4, this will be 5. Okay, and you also have -1. Okay, what is 1 minus, okay, 2 into -1? This is going to be a 3. Okay, so du by dx is equal to -2. Okay, meaning that du is a negative dx, or meaning that, let me make dx instead of du. So dx is negative du over 2. Okay, so let's go ahead and integrate this. And as a student, when you're learning something online, whether you physical presence of the teacher, always try to do what he's doing. Don't just sit and look at the blackboard. You'll be more of a passive learner. You get involved in the lesson, get your pen, okay, get your tab, whatever you have, start working out the integral as you follow what we are trying to do. Okay, so the integral from integral from -2 to -1 dx over 1 minus 2x will change to integral from 5 to 3, okay? And we are looking at 1 over u, dx changes to minus du over 2, okay? This is going to be negative a half natural logarithm of u, okay? Supposed to be natural logarithm of u, but what is u? 1 minus 2x. Then we substitute our limits, okay? From 5 to 3. And remember, the rule is upper limit first minus lower limit first, okay? So this is going to be a half natural logarithm of, oh, sorry, there is a very, very big mistake here. Okay, let me revise the mistake. And I tell you about, it is good to make a mistake so that learners can know when they make mistakes. And what do? We have changed the limits. We are no longer working with -2, okay? We are working with the 5 and 3. So if you change limits, you don't need to make a back substitution, okay? This remains u because you have changed the limits, okay? From 3 to 5. No, it's the other way. I don't know what's happening today. Okay, but take it easy. This is 5 to 3. All right. Okay. So what do we get? The answer will be a half natural logarithm of, okay, it's going to be 5 over 3. Okay, we don't need to add a constant of integration because we are given the limits. When you add a constant of integration, it's going to cancel out in the process of substituting the limits. So whenever you have limits of integration, I'll repeat this over and over again. Never bother yourself with the constant of integration. All right, let's look at some examples here. All right, we have been given this integral. They want us to evaluate, okay? A half integral from negative a half to positive a half of 1 over 1 minus x plus 1 over 1 plus x by dx. Okay, so it is quite easy. Let's look at the solution. You want to integrate halfway of negative a half to positive a half of 1 over 1 minus x plus 1 over 1 plus x by dx. This is simple. It is really straightforward. Okay. How do we go about these integrals so fast? Okay. This is going to be natural logarithm of the first part, 1 minus x. Okay. Now, you always go ahead and differentiate the denominator. Okay. The answer you get or the derivative you get the reciprocal and multiply by the natural logarithm. So this is going to be 1 over -1 natural logarithm of 1 minus x plus, okay, this the second natural logarithm of 1 plus x. When you differentiate, you get a 1 here. 1 over 1 is a 1, okay? Now it has limits, and remember, we are multiplying it by a half. Don't forget about that a half which is outside, from negative a half to positive a half, okay? Let me just, mathematicians, most when you have x, variable x, you may not want to use, multiplication sign. You can just use a dot to mean multiplication. That is okay. All right. So before we substitute the limits, we can go ahead and actually change this integral, using the laws of logarithm. This is negative and this is a positive. This will be equal to natural logarithm of 1 plus x over 1 minus x. Okay, because if I have log of a minus log of b, I end up with log of a over b. Okay, that is just a law of logarithm, something very simple that you have covered before, or we assume you have covered. And now the limits here are from negative a half to positive a half. Remember, we had a half before. Okay, so you substitute. Okay, 1 plus a half, that is 3 out of 2. Okay, and down 1 minus a half is a half, so a 2 cancels out. Okay, and the answer will be, so it is 1 plus a half, 1 plus a half, that's the same thing, which is supposed to be a half. Natural logarithm, up we have 3 over 2, down we have 3 over 2, because 1 minus, it is a, okay, let's not make a mistake, sometimes when you rush, you may end up failing. Let's substitute this. Okay, so it is a half of 3 over 2, down it is a half. Okay, minus now lower limit. Okay, lower limit, you are going to have 1 minus a half, so that's going to be natural logarithm of a half divided by 3 over 2. Okay, in any case, the 2 cancels out from the denominators, and this natural logarithm of 3 minus natural logarithm of a third. Okay, so this is going to be a half into natural logarithm of 3 minus natural logarithm of a third. Okay, 1 over 3. Okay, so or you can say 3 to the power negative 1. Negative 1 comes here, and then you end up with the just natural logarithm of 3 as the final answer. Go ahead and simplify this. We don't have to simplify everything for a learner. If you are to learn something in mathematics, okay, don't always try to ask the teacher to simplify up to the final answer. We leave some steps that probe some kind of thinking. It stimulates thinking within you. So you find out from this step how I come here. But the answer is natural logarithm of 3. I'm seeing a 2 cancelling with the that a half which has been, so that is it.